Okay. First, good afternoon for everybody. I thank Divik and Tiago and everyone presenting present on this online for this webinar. First of all, I'd like to say I'm thankful for CBT and BTS for the opportunity to be here today representing Brazil and sharing some offering innovations and technologies that we are applying in this important work here in Brazil. I'm appreciated the innovation, the invitation, and I hope that who is watching now, students, engineers, and other professionals, enjoy what are you doing in this amazing work. Okay, so I'm the design coordinator in this work. I'm the responsible for the designers, their interface between designers. I'm responsible for the topographic team and the geologists and instrumentation team. Okay, with me today there is another engineer, Gustavo, to help to talk about some topics and response any questions or doubts. Please, Gustavo, introduce yourself.
Hi, good afternoon. Hi, Devek. Hi, Tiago. Hi, Pedro. I'm Gustavo Santos. I'm 28 years old. Like Pedro, I'm a civil engineer as well. I worked in a building construction company and then an inspection building company. But now it's my first project here in Tamoios with tunnels and viaducts. My first huge project. Let's start, Pedro.
So let's start the presentation. So here we have a short presentation plan with some topics that we are going to talk about in the sequence. So we're going to say quickly about the company, the project background, and the overview, applied methods and technologies, accessibility and emergency and tunnel equipment, the reduction of environmental impacts, and the good practice of this contract. So we have here a resume of the group Queiroz Galvão. With more than 67 years of history, the company operates in national and international markets and has experience executing work with innovative engineered solutions in several sectors, such as infrastructure, such as highways, airports, bridges, pipelines, buildings, railways, subways, power tunnels, power generation, and the underground works. And in this segment, we have more than 300 kilometers executed. So, as we're talking about tunnels works, I'm gonna show quickly another important projects of the company. This work in Brazil, it was the Metro 4, is in the northeast of Brazil, as you can see in the map. It was a work with the method with the cut and cover with diaphragm wall. Here we have the line 5, the metro of São Paulo. We have here the method was the NTM and the TBM. In this case, the NTM was to did the shafts and the TBM for the tunnels. Here we have the line 4, the line yellow, São Paulo, the Metro São Paulo. The method used was the NTM and TBM. In this case, we have 4.6 kilometers of NTM tunnels and 6.3 kilometers of TBMs. Now here we have the line 4, but in this case in Rio de Janeiro, okay?
And this tunnel here, we used both NTM and TBM as well, with over a section over 100 square meters.
Have here the road tunnels. This one it was made for create a connection between the countryside of Minas Gerais, I stated here, a rich region in iron ore, to a region in the state of Rio de Janeiro, a steel industry region, and the Queiroz Galvão construction was hired to build a lot with almost 28 kilometers. In the total station of this project, it was 350 for 100 kilometers and almost 100 tunnels in the total. The biggest one with 8.6 kilometers. Some hydraulic tunnels. Here we have a work in Chile. It was a power station in Ligueira, in the city of Ligueira. In the total, we have 19 kilometers of NATM tunnels. Another one in another one power station, Queimados, now in Brazil, but in the southeast of Brazil. We had a total extension of 4.6 kilometers, and the method used was an ATM. Here we have the highway tunnels, important highway here in Brazil, the BR 101. It was in the south region, as you can see in the map. We used the NATM, soil and rock, and the section was 125 meters. The total extension was 3.7 kilometers. We have here the Rodonel Lot 5. It was a ring road around São Paulo. The total extension was 3.4 kilometers. The method used NATM to the rock excavation, 630,000 cubic meters of material. Here we have another work in progress. This one in Salvador, Bahia, a state of Northeast region. It is a connection between the littoral, the Atlantic coast, to the center of the capital of it is Salvador, the capital. This work have 3 tunnels and almost 12 kilometers with 3 lines each direction. Here we have to create a connection with the Tamoios and the port. I will explain better later, but this project in specific is going to connect the Tamoios highway when in operation, as illustrated in the next slides I will show. This work that we finished recently, I had the privilege to participate from the beginning. It was more than 12 kilometers of tunnels with a section of 105 square meters, and we used it to the NATM method, okay? It was a double tunnel with a section around 105 square meters. So now we've got to the point. Let's discuss about the Tamoios Highway. Okay, here's some key information for the project. This work is located in the north coast of São Paulo. The city it is Caraguatatuba. We have almost 13 kilometers of tunnels and 10 viaducts or 10 bridges. The method chosen was the NATM 2. And so let's start. The Tamoios Highway, it is a crossing the Serra do Mar State Park. The duplication of Tamoios Highway will provide more safety for the users with smoother ramps, less sinuous roads, and more open curves. In addition, it will improve the flow capacity of products to the port of São Sebastião, moving the economy the economy. Due to the differentiated technology solution to reduce impacts on the Atlantic rainforest, the project received in 2017 the Eco Sustainability Award from the American Chamber of Commerce, okay, an international entity. Here we have some technical information. So we have almost 22 kilometers of long main track. We have 6.1 of earthwork, 12.8 of road tunnels, including the biggest one in Brazil with 5.5 kilometers. And we have 2.5 kilometers of bridges. It's important to say that almost 85% of this work is inside this park, the Parque Serra do Mar. Is located in an environmental protected area and with several species of animals and plants. So more than 80% of these works is inside a protected area. So here we have a layout of the project. As you can see here, we will have the Tamoios Highway, the new one in the green line, as you can see here, is the what are we doing now? And this route will be the uphill way with 2 lanes and a shoulder, and they would be the old one. This yellow line will be the downhill way with 2 lanes too and a shoulder. From a technical point of view, the relief of the mountain make it difficult to build tunnels in this area, as we have a region with many valleys and hills associated with heterogeneous geological conditions. The weather conditions are another important factor, since we are talking about a tropical forest. Okay, as you can see in this picture here, we have the plateaus, the top of the mountain here, and we have the plains in the level of the sea, and we have a height difference in almost 650 meters. And with this, we can see the difficulty of the topography, the climatic conditions, and another aspects.
Yes, those were the big challenges here, to bring the highway from the top of the mountain to the sea level, and also to build the viaducts and tunnels inside a protected area. So I think if we summarize, those are the challenges.
So here we have the layout of the project, the total project. As you can see, we will have the Tamoios Highway, the connection with these roads, the contour works. So we have the yellow line is the duplication, the uphill way, and we have the red one and the blue one. It is the contornos works. Okay, the contorno works connect with the Tamoios, and with this lead to the port of São Sebastião, an important logistics center in this region. This port, in special, has a better conditions of operation than the port of Santos, one of the main Brazilian ports. Okay, it's a secondary port for the state. With this, we have a important project for the economy of the state and the economy of this country. Okay, so we have here the layout of the work, the Tamoios duplication. Here we have the actual road, to access the north littoral, and we have here the old one, as we name here. This project includes the construction of 10 viaducts as you can see here in yellow, and 4 tunnels. In the total, we have a stretch of 21 kilometers of extension. We have 4 tunnels. The tunnel 1 with 2.9 kilometers. The tunnel 2 with less than 1 kilometer. The tunnel 3 4, 5.5, the big one, and the tunnel 5 with 3.7 kilometers of extension. So we have here the viaduct 6 with almost 1 kilometer of extension. Okay. So we have here a board with contractual data. The client, it is the concessionaire Tamoios. The source of resource, the state. We have the investment close to 600 million pounds. So for here, it is a biggest work. It's a big work. The service award was April 2015, and the deadline for March 2022. Today we have a physical advance in around 78%. The object of this contract is the implementation of the Novo Tamoios Highway and the duplication between the kilometers 60 and 82. So we have here this board. This table presents the main quantities of this project. So we have here a resume, 4 tunnels, 10 bridges, earthworks bridge, the largest bridge with 948 meters in the total station of this project. The main quantities of the service, we have the excavation more than almost 2 million cubic meters of excavated material, concrete paving and asphalt paving, almost 50,000 cubic meters, shotcrete and structural concrete around 260,000 of concrete cubic meters. So we have here a sum up, we summarize some topics, and we are going to talk about the sequence. We have the utilization of TCADE, the software TCADE, the section scan, the cable crane assembly, the tunnel 2 breakthrough, and the viaduct 1A. So we have here the applied methods and the technologies of this giant work. So you have here, just to explain, the NTM is a commonly used excavation method using the drill and blast technique, consisting of rock drilling and detonation of explosives in the tunneling fronts in rock masses. So we have some stages of the cycle. And Gustavo, if you want, you can put some.
Sure. It's a pretty common method. First, we have the geological mapping with the topographic team. Then the front drilling with the boomer. After this, we have the explosive loading. Then the detonation. And after that, we have the ventilation system for the gas removal. Then we have both mechanical and manual scaling. And finally, the shotcrete, our sprayed concrete here. And the cycle repeats over and over until the tunnel is done.
We have here the emergence tunnels. For reasons of regulation of the fire department, tunnels over 3 kilometers must to have a pedestrian crossings every 250 meters for better evacuation in case of fires or accidents. For this case, Along the three tunnels, Tunnel 5, Tunnel 3-4, and Tunnel 1, there is a parallel service tunnel. Only Tunnel 2 doesn't have an emergency tunnel because it's less than 1 kilometer long. All the passages will be fire protected. So we can see, so let's return here. The main section, we have a cross section here of the double tunnel. We have the main section with 120 square meters. We have the cross passing. The distance between them was around 16 meters. And we have here the service tunnel with 33 square meters of section. So, as we said before, every 250 meters we have to have a connection tunnel. But in this case of the tunnel 3-4, as we are talking about a tunnel with 5.5 kilometers, the fire department regulation demands a massive extraction or a ventilation tunnel. Okay, this ventilation tunnel will be equipped with 6 fan jacks with 150 horsepower each one, which will be activated in special cases such as fire or high gas concentrations. So we have here the service tunnel and the main tunnel, and between them there is a chamber with the power plant, and we can see here the six fan jets for the massive extraction. Okay, so we have here a plant view, and we can see in this region we have many types of excavation section in the same region. The main section, the service section, the connection, and this shaft section. We can see here through the chamber with the operation, a controller room, and a power plant of this tunnel when in operation. Okay. So here we will say about the boomer system. It's not innovation, but as we're talking about work with 80% of tunnels, it turns a crucial tool to perform the tunnel cycle and the excavation control. We bought in the beginning of this work 6 equipment like this. This model in specific has 3 booms and the TCAD system. We have some here examples of the reports. We can export some information like drilling speed, the water pressure, hose depth, and another important data for the operator at real time. So we have a significant improvement in the drilling accuracy, decreasing the amount of under and over break, reducing with this, of course, the waste of material involved in drilling. And this is a partnership with Sandvik, a Finnish company, and all the operators was training and the maintenance equipment to control and to optimize the entire cycle of activities related to the jumbo. Okay, so we have here the topographic equipment. We have here a total station. It is a robotized station, and this equipment is responsible for the geopositioning of the jumbo, and is located the drilling holes and maps the excavation section. With the aid of the systems, an autonomous system, we are able to collect information and compare section in real time. Okay, so this technology guarantees the treatment and under break points and drilling adjustment for the next blasts, minimizing rework and loss from over excavation. Okay. These slides represent the important stage is the stage relate which the topographic team is responsible. Is one of the most important team in underground works. Here are all the service the topograph team executed in a tunnel excavation. As you can note, they participated in all stages of the excavation cycle. So we can control the quality of lining. We can have the real-time profile. We can back up and set up the section and another service that we can control in real time. Okay, in the shotcrete time, all the treatment, all this, the excavation and others. So here we have. It's important to mention this work in Brazil today is the first one to to
use only polypropylene fibers to resist fires and structural loads.
This can be achieved applying in the shotcrete mix an addition of micro and macro fibers. Okay, it's important to mention again. We are doing some pioneer thing here in Brazil because we are doing the tunnel lining with 100% of synthetic fibers, and this solution improves for the shotcrete and for the cycle of excavation other advantages. Another interesting point is that with these results obtained in this work, we are preparing together with other technical institutes the Brazilian standard for the concrete reinforced with polymeric fibers. Okay, for this it is an innovation of this work.
Yeah. Changing the steel mesh for these fibers, we are achieving greater work without a more safer way, a quicker and cheaper way is the result of this change.
So this is a not innovation system, but we choose this solution because any factors of this work, and there are some points that we can talk here. The system allows the adherence between the first shotcrete line and the second one, preserving the friction between both layers, allowing a significant reduction on its final thickness, providing with this, of course, a financial and a time economy in the cycle of excavation too. It has a lot of advances over the waterproof membrane system, a usual system. It is a not systematic treatment, therefore not only cheaper but also easier to apply. Dealing with infiltrations with high flow rates, as commonly find in tropical regions and rainforests, reduce groundwater pressure over the lining, avoiding overload due to extreme climatic events. And when necessary, we can combine this system with short drams, as you can see here in the image, and a polymeric mortar in order to maximize its efficiency. So nowadays, the environment is a central subject in discussions about the society in the last decades. When we were studying the project, our prime goal was to attend the environmental and the contractual regulations, and the good practice of engineering. So let's talk about the most important and the innovation of this work, the cable crane. So from the beginning of this project, the company looked for different solutions around the world to avoid the execution of this service way, as you can see here in this orange line. Okay, that would suppress more than 400,000 square meters of rainforest, a big impact in the Atlantic Atlantic forest. Because our short deadline, we had to start the viaduct tree and the tunnel tree at the same time. That's why we had to employ this pioneer technology in Brazil. So it's the first cable cable crane assembly here in Brazil. So it was a hard mission to do this for the first time. Okay. As you can see here in this overview, we designed the position of the track rope, the red one line here, aligned with the main supports of this bridge to aim the execution of foundations, columns, and other structures of this viaduct here.
Yes, the track hope is right here. It's placed here because of the viaduct here, the main supports, and also to help in transporting the rocks from the tunnels to its final destination.
So let's talk about the cable crane mounting details. In the case of Tower 2, we could assemble with crane, regular crane, because we had enough space to do the operation. As you can see here, we have all this space and we can do a regular or standard operation. However, for the Tower 1, that was not possible. This region here was unreachable. As you can see, the helicopter and all this earthwork here. That's why we decided to install each piece using a helicopter. As you can see in the video, this is the tower one. This is in remote region inside the park. Okay, so it was so hard to have this liberation of the park to do this operation, but we can prove that that wasn't impact with this operation. So we have a partnership with the Omni. They're responsible for the helicopter, and another partnership was the LCS, the cable crane construction. But all the project was made together with LCS, the Omni, and the Queiroz Galvão. Okay, so all this operation was made together. We have here some technical informations about the cable crane. The distance between towers, the tower 1 and tower 2, it is 394 meters. The track rope, the diameter is 65 millimeters. The load capacity, about 20 tons. The travel speed, 4 meters per second. And the turret height, tower 1 with 42 meters and tower 2 with 35 meters. As you can see in the videos, we can carry any types of equipment.
Yes, yes, I was in charge of the night production shift here in Tamoios, and the cable crane was essential. Every steel bar, every concrete, every framework, every equipment in general was transported by the cable crane. So it helped and was essential.
So we have here some operational data. The period of operation was since March of 2019 until August 20. We worked seven 7,100 hours. The soil rocks transportation more than 220,000 tons. The concrete volume more than 10,000 cubic meters, and the mechanical availability approximately the 90% of utilization of this equipment. So it was very efficient for this work and very important to us for for the conclusion of this bridge. And we can anticipate the deadline of this bridge in almost 2 months, and we can anticipate the tunnel close to 5 months. So we have here another solution, the pedestrian walkways for optimize the path along the viaduct tree and to access the main supports. With this, we can reduce the dislocation time of the workers, and we can avoid unnecessary suppression below the bridge. Okay, we can see here the tower, the height of the tower, almost 30 meters of height, and we can assemble this tower with the aid of the cable crane too. Okay, so for this the cable crane supports all the operation in this assembly. So in the basic project, we expect to have an impact over 700,000 square meters. However, with the all engineering solutions, we had a positive impact, reducing close to 40,000 square meters of suppression at the Atlantic forest, the equivalent to 6 football fields like the Wembley Station. So we can see the reduction was very important for the this work, and we can finish this bridge and the cable crane supports for this goal. Now let's talk about the water treatment stations. Just to we have an idea, during the drilling process of the tunnel, the boomer consumes about 40 cubic meters of water per cycle of excavation. So a work like this, with this proportion, we can consume close to 400 cubic meters per day. So the system was developed in closed circuit. All the captured tunnel effluents, the infiltration water or post-drilling water, passes through the treatment station. Therefore, there is no risk of dirty water disposal, providing protection for the environment and reducing the operational costs. So we have here each tunnel have a water treatment station to treat all the effluents. We can see in this graph here the total volume in 2019 in cubic meters. We treated more than almost 300,000 cubic meters. the reused water was 120,000 of cubic meters, and discarded water and concrete plant water volume, that is another volumes of water, all them treated. Uh, you use more volume of treated water than our well. So with this, we can avoid the unnecessary natural water consumption. We we prime our primary reused water destination, it is the tunnel drilling to attend to the demands of the jumbo, the equipment washing, the crushing plants, and the access routes for route ratting. So for just for we have
An idea of how much.
we treat
Yes.
in 1920 we treat the equivalent to 115
Yes.
Olympic swimming pools. So we can see other images and the quality of this water. We control all the parameters like pH, like another
Sulfates.
sulfates and another parameters of control of this water. And this water is potable, portable. So we have here the crushing plants. This is a substantial project, and the total volume of the earth moved include rock generated by the tunnel excavation will reach 2 million cubic meters. Much of this excavated material will be used in concrete, in the asphalt plants, and the soil plants. The volume necessary to all civil works will demand more than 300,000 cubic meters of concrete.
Yes, basically we take the rocks from the tunnels, we drill, and then we have the crushing process, getting the gravel and the rock filler, and we use them in the shotcrete, in our sprayed concrete, in our concrete, and in our paving, reducing natural waste and costs.
So another solution we have here is a situation of the tunnel to breakthrough. So that we didn't have access to, as the case of the viaduct tree and the tunnel tree, to assess the other side of the tunnel excavation. But in this case of tunnel 2, due to environmental limitation, we had to dig from just one side. With that, we had to break through the tunnel from the inside out. Okay? To save the time in the execution of the viaduct, we, we thought in a solution to assemble the viaduct inside the tunnel and then push it with hydraulic jacks over the supports. So with this, we can save time and we can uh, deliver for the client this bridge in the deadline as the
The demand.
the demand. So that's for the good practice of this contract. So we have here some items that we summarize the another points or the some points. Principal and service tunnels approximation. We adjust the reduce we reduce the interconnection tunnel length, decreasing the total area of treatment and the suppression even. The shotcrete technology control, the use of 100 filler, and the PP fiber, the polypropylene fiber in the shotcrete mix design. And with this, we did not use a natural sand in the mix, improving with this efficiency in the results and the quality parameters, and reducing the need for material deposits. The cable crane assembly, a solution for reducing the environmental impact and making the executive schedule viable. In the first time in Brazil, a pioneer. Uh, and the tunnel 2 broke through in Viaduct 1A. It was a differentiated solution, saving time and protecting the environment. So with this, I think we finished the presentation, and we have here some contacts. We have here my email for any questions. We have the construction site and another social medias. Okay, for I think is this for today.